Hello guys, welcome to our channel Niperian Solutions. So today we are going to discuss about the mass spectroscopy. Okay, so let's discuss all the questions one by one. Okay, the first question is how much energy required to remove one electron from an atom or molecule? Right? So what are the options? 70 electron volt, 10 to 15 electron volt, 100 electron volt, or none of the above. Right? So what is the correct answer here? Yes, that is the 10 to 15 electron volt, right? Don't get confused in between the 70 electron volt and 10 to 15 electron volt. Let's discuss. When a molecule, right, if any molecule is there, if you are giving energy the 15 electron volt, so one electron is removed from there, right? What is our question? We have to remove the one electron, right? So if you are giving the energy of 15 electron volt, then and then only one electron is removed and the m plus radical formed, right, by removing the one electron. So what is the radical? That is the radical cation, right? And that is our molecular ion peak, right? So what is our molecular ion peak? Means if one electron is removed from your molecule by giving the energy of 15 electron volt, that is our the molecular ion peak. And molecular ion peak is nothing but your the molecular weight of your compound. Whatever the molecular mass that you are getting, that is nothing but your molecular ion peak. Okay, and again that radical cation or your molecular ion, if you are giving the 70 electron volt energy, then it will form a different fragment. So that how we will give that 17 electron volt energy? There are the accelerating plates in your mass spectrometer. So that's why that 15 electron volt get converted into again 17 electron volt for your again fragmentation of your compound, right? Because just molecular ion you are getting your molecular weight, but what are the different fragments you are forming in that one? So that is totally depending on your the energy of 17 electron volt. And what are the that fragment ion form? These are the cation, radical, neutral molecules and radical cations, right? Okay, so the next question guys, the nitrogen containing compound with an odd number of nitrogen atom in the molecule must have, right? So I hope this is clear to you. So that question is related to your the nitrogen rule, right? In mass spectrometry, very important nitrogen rule is there. So what are the options here? First one is the odd molecular mass, even molecular mass, odd and even molecular mass, and all of the above. So what is the nitrogen rule here, right? So what is the correct answer here? What question is asking to us? The nitrogen containing compound with an odd number of nitrogen, right? So what is the answer here? That is the our odd molecular mass. Why? Okay, let's discuss the nitrogen rule, right? So just simply here you can see, just see this one here. Simply the odd number of nitrogen present in your molecule, then molecular weight should be the odd one, right? And if even number of nitrogen present in your molecule, then your molecular mass should be the even, right? If there is no nitrogen present in your molecule, then and then only even number of, right? So means like molecular weight is also even, right? I hope this is clear to you guys, the nitrogen rule. Okay, the next question, what is the intensity ratio of chloro compounds in your mass spectrometry, right? So what is the intensity of chloro compounds? Because we know the halogens like chlorine and bromine, these are the isotopes and these are showing the different intensities. Like if you are looking the mass spectra of the chlorine and bromine, so due to their isotopes they are showing the different intensity, right? So here they are asking the chloro compounds. So what is the intensity ratio for the chloro compounds, right? So that is the 1:3, right? So 1:5, that is the nothing. Okay, 1:1, that is for our bromine, right? That is for our bromine molecule. And 2:1, that is also nothing, right? 1:3 and 1:1 you have to remember. Just we will discuss how. Okay, if you are looking here, if the intensity ratio of 1:3, then these are the chloro compounds, and for 1:1 these are the bromine compounds. Like the molecular ion abundance of a particularly alkyl halide increases as the electronegativity of the halogen substitution decreases, right? So it is totally depending on the what type of halogen attached over there, and you have to remember the electronegativity order also. So fluorine is the highest electronegative atom in that row, right? Then chlorine, then bromine, and then iodine. So here guys, you can see the different two spectra, right? This one and this one. So we are talking about the first one, okay, this one. So what is the compound here? That is the ethyl bromide, okay. This spectra is of ethyl bromide, sorry, okay, this one, ethyl bromide. So in ethyl bromide, so bromine is there. So what is the intensity? 1:1, right? So these are the two isotopes, 79 and 81. You can see these are the two isotopes of your bromine, and the molecular weight of that ethyl bromide is 108. The M plus peak, you are right. So the M plus peak is 108, and the speciality of these molecules, they are showing the M plus 2 peak also, right? Chlorine also and bromine also, right? These isotopes are showing the M plus 2 peaks. So that is the speciality of these compounds. So here 110, that is the M plus 2 peak is also showing, right? Similarly here you can see in this one the example of ethyl chloride, right? So here the intensity of that 108, sorry, in the ethyl bromide, the intensity of 108 and 110, that is the 1:1 ratio here, right? But in here in chlorine, that is the 1:3 ratio, right? Means M plus 2 peak and M plus 1 peak, whatever the peaks they are observed, that the intensity ratio is 1:3 in your chloro compound. So just remember the thing, guys. So you have to remember, for the chlorine compounds the intensity ratio is the 1:3, and for bromine that is 1:1. Okay. The next question, in McLafty rearrangement, right? So that rearrangement is very important in mass spectroscopy, McLafty rearrangement. So what is the requirement of that rearrangement? Okay, so first alpha hydrogen and alpha cleavage, second gamma hydrogen and alpha cleavage, beta hydrogen and gamma cleavage, gamma hydrogen and beta cleavage, right? So what is the correct answer here? That is the right gamma hydrogen and beta cleavage. In second option gamma hydrogen is there, right? Here gamma hydrogen is there, but the cleavage is alpha, so that's why this answer is wrong, right? So in McLafty rearrangement always gamma hydrogen is a requirement and beta cleavage. Here in hydrogen I think spelling mistake is there, but I think you can understand, right? So gamma hydrogen and beta cleavage is the basic criteria for McLafty rearrangement reaction. Okay. Okay, here is the McLafty rearrangement. So it involves the migration of gamma hydrogen atom followed by the cleavage of beta bond, right? The rearrangement leads to the elimination of neutral molecule. That is also very important, right? So whatever the groups they are having, means the any functional group, these are having the gamma hydrogen present in that. So these molecules only goes in the McLafty rearrangement, right? So similarly in butanol, right? The example is butyraldehyde or the butanol. So in that one here, so this carbon is alpha, beta and gamma, right? So whatever the hydrogen present on the gamma, that is transferred to that oxygen. Here you can see in the molecular ion mass to charge ratio is 44, and here is the product, right? So means that gamma hydrogen transferred to the electron deficient atom, that is the nitrogen over there. Okay, and again the cleavage is in the beta bond, right? So that first bond and this is the second bond, so beta bond, so here it will cleaved. Okay, so similarly, so these two molecules are formed, like, so this is the neutral molecule, you are forming CH2 double bond CH2, you can see over here, and this one is our molecular ion, right? So means this one molecule. I hope this McLafty rearrangement is clear to you guys. Okay. Okay, so the next question, the stability of the carbocation has the order, right? So as we know, where we have seen that stability of carbocation, basically we are seeing in our like SN1 and SN2 reactions, right? So here are the questions, like the what is the stability. So here again they have added allylic group and methylic group. So you have to go with all these groups, like allylic, tertiary, secondary, primary and methyl, right? So similarly that all the options are there, tertiary, secondary just. So what is the correct answer here? That is the option A, right? So means allylic carbocation having the highest stability, then tertiary, then secondary, then primary and then methyl group. Okay, I hope this is clear to you. The next one, if the aromatic ring is substituted by an alkyl group, a prominent peak is formed at. Very simple question. बस थोड़ा सा घुमा के उन्होंने पूछा है. Just you have to remember that the aromatic ring is present over there and that is substituted to the alkyl group, right? So here the aromatic ring and it is substituted to any kind of alkyl group, or you can say the just R. Okay, so what is the prominent peak is formed? So you guys also very know that key if any alkyl group attached to that aromatic ring, so that is the tropylium cation form, right? So what it is formed, that is the tropylium cation. And what is the molecular weight of that tropylium cation? Yes, that is nothing but our 91, right? So how that rearrangement is formed, if you are any alkyl substituted to that of aromatic ring, then we will see here. Okay, here are the two different examples. One is the benzene and the that second one is whatever they are asking, that is the second one, right? This one. And here is the benzene. So what is the parent ion in the benzene? By losing that electron, that is the 78, and finally mass to charge ratio is 77. But in tropylium cation, right? So the tropylium cation, that is the mass to charge ratio is 91 by rearranging the molecules in the mass spectroscopy. Okay. Okay, here are also some examples which are forming the tropylium cation. And finally, after tropylium cation, again loss of there that acetylene molecule is there. So the finally this molecule is formed, right? And mass to charge ratio is 65. So that is also characteristics of your whatever the mass is formed after the tropylium cation, right? So each and every time they are losing the same molecule and mass to charge ratio is 65. Means in second example also you can see here, right? Okay, in the second example you can see the tropylium cation is also formed, and in this molecule again gamma hydrogen is present. Means here Mac-Lefty rearrangement is also possible, right? So in the second molecule the two types of fragmentation are possible. First one is the Mac-Lefty rearrangement and the our tropylium cation also formed, right? So these are examples only for your practice. So you have to like remember, so what is the Mac-Lefty rearrangement, what is the tropylium cation. So these are very important in your mass spectroscopy. Okay, next one, the molecular ion peak is not detected in primary alcohols, secondary alcohols, tertiary alcohols, all of the above, right? So what is the correct answer? Our answer is tertiary alcohol, because in tertiary alcohol molecular ion peak is not detected, right? In primary, even in primary and secondary alcohols, the abundance of that molecular ion peak is very low, very low in primary and secondary alcohols. Means that alcohol functional group itself is there, means very negligible molecular ion peak is there in the alcohols. But tertiary alcohol is not giving any molecular ion peak, and primary and secondary alcohols giving very low intensity peak. If they are asking like if means they are giving any all functional groups like molecular ion peak is not detected in amines, acids, alcohol, right? So if they are giving these kind of options, so directly you can go with the alcohols, right? Because alcohols are not detected in means not detected means like these functional groups is molecular ion peak abundance is very low in alcohols, specifically in the tertiary alcohol. So depending on the question we have to go for the answer, right? So that's why you have to read the question very carefully. Okay. Okay, the next one, the most abundant ion formed in the ionization chamber gives the tallest peak in mass spectrum is. Okay, very simple question, everybody knows what is the tallest peak. That is nothing but our base peak. Yeah, everybody knows the base peak is the most abundant peak and the tallest peak. Just you have to remember these two words, most abundant and tallest one, that's the base peak. What is the molecular ion peak? Molecular ion peak, just previously we have seen, just by removing the one electron, and how much energy is required for the molecular ion peak, that is the 15 electron volt, right? And what is the like that molecular ion peak is also called as, that is the radical cation. Okay, so these are the small things guys you have to remember, very important. Okay, the base peak is always tallest peak in the spectrum, and it represents the most common and most abundant ion, just we have seen. And what is the molecular ion? That is also we have seen, that is the heaviest ion, and by removing the one electron from your molecule, that is the radical cation peak. Okay, here okay, chlorine and bromine, here are the different isotopes. The chlorine also having the two isotopes, and bromine are also having the two isotopes. right? Chlorine 35 and 37, bromine 79 and 81, right? So what that relative abundance is very important. So for chlorine 35, the relative abundance is 75.77%, and for chlorine 37, that is the 24.23%. So similarly in bromine, the relative abundance for 79, that is the 50.5%, and for 81, the relative abundance is 49.5%. Here are the different formulas for the molecular mass and the calculation of resolution, just for your information. Okay, so the next one, which among the following does not show the characteristic peak m plus 2? Okay, so previously just we have seen, right, which compounds are showing the m plus 2 peak. Okay, right? So we know the chlorine is showing the m plus 2 peak, bromine is also showing 1 plus 2 peak. Okay, so these two we know these are showing the characteristics peak of m plus 2. So what is remaining? That is the sulfur and oxygen. So among these, which one is, what is our question? Question is does not show. Okay, so chlorine and bromine, that's these are the showing the m plus 2 peak. Then sulfur is also showing the m plus 2 peak. Means what is our answer here? That is our oxygen. Oxygen is not going to show any m plus 2 peak in your mass spectroscopy. So just remember guys, this question is very important. Chlorine, sulfur, bromine, the characteristics peak m plus 2 is there in this compound, but oxygen is not giving any molecule. These are not giving the m plus 2 peak. So you have to remember these three compounds: chlorine, sulfur and bromine. Okay, next, which among the following does not use a magnetic field to separate ions of varying mass? Right? So field ionization, chemical ionization, time of flight, and FAB, that is the fast atomic bombardment. Right? So these are the different options. So does not use a magnetic field to separate ions of varying mass. Okay, so what is the correct answer here? That is nothing but our time of flight. Right? So time of flight, this is the mass analyzer also, time of flight mass analyzer or time of flight instrument. Right? So in field ionization, yep, definitely they are in field ionization as well as chemical ionization. They are showing the like, or they require that ionization, right, magnetic field. But in time of flight, this one is not like use a magnetic field for the separating of that ions. Okay, and that chemical ionization, that is also very important, because in chemical ionization it is also like called that as soft ionization technique. Right? Chemical ionization is a soft ionization technique. Okay, okay, so the next one, which among the following rule is applicable to mass spectroscopy? So here are the different rules. So Huckel rule, rule of 13, Hooke's law and Beer-Lambert's law. So Huckel rule is related to, right, that is the aromaticity. Okay, then rule of 13, okay, this one is related to our mass spectroscopy. Hooke's law is related to, yes, previously we have seen in the IR spectroscopy for the calculating of the vibrational frequencies. So Hooke's law is there, and Beer-Lambert's law. So everybody knows Beer-Lambert's law is for our absorption is directly proportional to the concentration and the path length, and it is related to the UV spectroscopy. Right? So what is the correct answer here? Right? That is our rule of 13, that is related to the mass spectroscopy. Right? How to use that rule of 13? If sometimes they are giving the molecular weight of your compound, right, so you have to calculate the molecular formula, right, from the molecular weight. So whatever the molecular weight they have given, you have to divide by 13, and then you will calculate the number of carbons, right, and from that carbon and whatever the data they have given, so you have to calculate all the molecular formula of that compound. Okay, the next, what is the name used to refer the type of ion represented by M plus radical, right? Okay, so just previously we have seen. So what is that M plus radical? That is nothing but our radical cation or the, right? So what is the correct answer here? That is the radical cation, because cation is also there, right? Then radical is also there. So combinedly it is called as the radical cation, and it is also called as, yes, what it is? Radical cation is also called as, that is the molecular ion peak. Okay, this means that is the only peak in your spectra which is giving the molecular mass of your compound. Okay, chalo next. What is the typical energy of electron used to ionize analytes by electron ionization? Okay, means there are the different techniques like electrospray ionization, chemical ionization. So specifically they have asked in the electrospray ionization or the electron ionization, so how much energy required in specific that technique, right? So 50 electron volt, 70 electron volt, 1 electron volt and the 15 electron volt. Okay, so what is the correct answer? That is the 70 electron volt. In electrospray ionization, 70 electron volt energy is required for the fragmentation of your compound, right? So what about the 15 electron volt? That is just for your molecular ion formation, means whatever the mass, so the 15 electron volt is there, so whatever the molecular mass of that compound, it is formed over there. But 70 electron over, that is the further for the fragmentation of your compound in the electron ionization technique. Okay, the next one, which of the following classifies chemical ionization most accurately, right? So what are the options here? A hard ionization technique, soft ionization technique, neither hard or soft ionization, a desorption ionization technique. So just previously we have discussed what is the chemical ionization, which type of technique is there. That is nothing but our a soft ionization technique, right? Chemical ionization is a soft ionization technique. So please remember this, guys. What does ICP-MS stands for, right? So what is the ICP-MS? Because MS is having also different categories, LC-MS, HR-MS, GC-MS, ICP-MS and all, means all the spectroscopy, all the mass spectroscopy is combined with different techniques according to their applications. So here they are asking about the ICP-MS, right? So the options are inductively coupled plasma mass spectrometry, inductively coupled proton mass spectrometry, intensively coupled plasma mass spectrometry and interaction coupled proton mass spectrometry. Okay, so what is the correct answer here? That is our option A, right? Inductively coupled plasma mass spectrometry, right? So what is the ICP-MS? That is the inductively coupled plasma mass spectrometry. So similarly GC-MS means like the gas chromatography coupled with your mass spectrometry. In LC-MS और हम उसको बोलते हैं कि लिक्विड क्रोमेटोग्राफी, राइट? द LC-MS मीन्स लिक्विड क्रोमेटोग्राफी coupled with your mass spectrometry, right? So accordingly these techniques have been developed. What is the purpose of the matrix in Maldi ionization? Okay, to provide a suitable solvent for the analyte, to promote multiple ion formation, to absorb laser energy and form radical ions, to enable the analyte to crystallize, right? So what is the correct answer here, right? So it name itself indicate, no need to worry, the name itself indicate what is the Maldi. That is the matrix assisted laser desorption ionization. What? Matrix assisted laser desorption ionization. So laser itself indicate, right? So the correct answer is to absorb the laser energy and form radical ions. Okay, so that is the function of our Maldi. Okay, so the next one, name an ionization technique which uses a coronal discharge needle to form a molecular ion prior to charge transfer with an analyte. So simple, which of the following simply uses a coronal discharge needle? That is the simple question, right? In among the following, which one technique is like based on the coronal discharge needle, right? So first one is the EI, that is the electrospray ionization. Then APPI, atmospheric pressure photoionization. Then Maldi, then atmospheric pressure chemical ionization, right? So what is the correct answer here? That is the APCI, that is the atmospheric pressure chemical ionization, because in the APCI the coronal discharge needle is used to form the molecular ions. Okay, right? Okay, so thank you guys. So these are the very important question from the mass spectrometry. So you have to read each and every question very carefully. So from all the spectroscopy, so today we have completed that like all the important spectroscopy, right? So UV we have completed, NMR we have completed, mass we have completed, and IR also we have completed, right? So in the next video we will see what kind of topics that were important for your FDA exam as well as for the all like technical part, right? So stay with us guys. So please subscribe the channel and share with your friends. Okay, thank you so much.